Hello everyone. In this video, we are going to see some applications using loops, including using loops to create samples, and reading a list of external files. This video is based on Chapter 5 in Handbook of SAS Data Step Programming Book. In some situations, we may want to draw samples from a dataset. By default, SAS sequentially reads one observation per iteration of the data step. This process will stop when an end-of-file marker is reached. Instead of reading data sequentially, SAS can also access an observation directly, via direct access mode. There are three important components for using the direct access mode. First, we need to tell SAS which observation we would like to select. This step is performed by using the point equals option in the set statement. The variable specified by the point equals option is a temporary variable, and it is not outputted to the output dataset. This variable is set to 0 in the PDV, at the very beginning of the data step. Then it must be assigned to an observation number, before the set statement. For example, this program creates a dataset that only contains the fifth observation of the SBP dataset. To select the fifth observation, we first create a variable OBSN, and assign value 5 to this variable. This variable is then specified in the point equals option, in the set statement. In the second step, we need to tell SAS when to stop processing, because when using direct access mode to read data, SAS will not be able to detect the end-of-file marker. Without telling SAS explicitly when to stop processing, it will cause infinite looping. Therefore, to utilize the direct access mode, we need to use the stop statement at the end of the data step. Recall that SAS writes observations from the PDV to the output dataset at the end of the data step, if there is no explicit output statement in the data step. However, if we use the stop statement, the data step processing will stop before the end of the data step. The implicit output will not be reached. Thus, the last step to using direct access mode is to write an explicit output statement before the stop statement. Drawing samples from a dataset can be categorized into drawing systematic and random samples. Creating a systematic sample is to create a dataset by selecting every k observation from an original dataset. The systematic sample cannot be created sequentially, hence, a direct access mode must be used. We can create a systematic sample by using an iterative do loop. Recall that constructing an iterative do loop requires providing start, stop, and increment values. Normally, the start value is set to 1, the stop value is set to the total number of observations from the input dataset. The increment value is set to k, which indicates every k observation that we want to select. One way to determine the total number of observations is by utilizing the NOBS equals option in the set statement. The variable specified by the NOBS equals option is a temporary variable that contains the number of observations in the input dataset. It will not be written to the final dataset. The variable is created automatically, based on the descriptor portion of the input dataset, during the compilation phase. It will retain its value throughout the execution phase. Here is the program to create a systematic sample that contains every third observation. Let's go over the execution phase to understand this program better. The automatic variable _n_ is set to 1 throughout the execution phase, because SAS didn't read the input data sequentially. At the beginning of the execution phase, the variable choose is set to 0, the variable total is set to 9, based on the descriptor portion of SBP. The rest of the variables are set to missing. At the beginning of the first iteration of the do loop, choose is set to 1. SAS reads the first observation from SBP into PDV by using the direct access mode. The output statement copies the contents from PDV to the output dataset. SAS reaches the end of first iteration of the do loop. At the beginning of the second iteration of the do loop, choose is incremented to 4. Since 4 is less than, or equal to 9, the second iteration continues. SAS reads the fourth observation from the input data to the PDV, via the direct access mode. The output statement copies the contents from the PDV to the output data. SAS reaches the end of the second iteration. At the beginning of the third iteration, choose is incremented to 7. Since 7 is less than or equal to 9, the loop continues. SAS reads the 7th observation from the input data to the PDV, via the direct access mode. The output statement copies the contents from the PDV, to the output data. SAS reaches the end of the third iteration. At the beginning of the fourth iteration, choose is incremented to 10. Since 10 is greater than 9, the loop stops. The stop statement stops the data step execution. Now, let's see an example of creating a random sample. A random sample is created from an original data set on a random basis. A random sample with replacement means that an observation is returned to the original data set after it has been chosen. Hence, any observations can be chosen more than once. An important step in creating a random sample with replacement is generating a random number that indicates which observation needs to be selected. When we create a systematic sample, the variable choose is incremented by k at each iteration of the do loop. To create a random sample, we need to generate a random integer between 1 and the total number of observations. To select observations randomly, an integer between 1 and the total number of observations needs to be generated within each iteration of the loop. The ranUni function generates a number between 0 and 1. When multiplying this generated number with the total number of observations, the resulting number will be between 0 and the number of observations. Since we need an integer value, we can use the ceil function, which returns the smallest integer that is greater than or equal to its argument. This program shows how to create a random sample with replacement. You can check out the example in Handbook of Data Step Programming for creating a random sample without replacement. Next, we are going to see an example of using an iterative do loop to read external files. To read an external file, we need to use the infile statement to identify the file location. For example, this program reads an external file, text1.txt, which is in the C drive. Since there are 2 observations in the external file, SAS will use 2 iterations in the implicit loop to read the data. When SAS reaches the end of file marker, it stops reading. Alternatively, we can use an explicit loop to read an external file. To construct an explicit loop, we need to either specify the number of iterations for the iterative do loop, or we need to specify a condition for the do while or do until loops. One way to specify a condition is by telling SAS to read the observations until it reads the last record. For SAS to detect it has read the last record, we can create a temporary variable by using the end equals option in the infile statement. The variable specified by the end equals option is set to 1 when SAS reads the last record of the external file, otherwise, it sets to 0. The variable that is created from the end equals option is not sent to the output dataset. In this program, the data step execution only iterates once. Within this single iteration, the do until loop iterates twice to read the 2 observations in text1.txt. Before we see an example of reading multiple external files, one more option of the infile statement needs to be reviewed. In the infile statement, we generally specify the name and the location of the external file immediately after the keyword infile. Alternatively, we can use the FILEVAR equals option in the infile statement to read an external file. Like any automatic variable, the variable specified in the FILEVAR equals option is not sent to the final dataset. This variable contains the name of the external file and must be created before the infile statement. When we use the FILEVAR equals option, the file specification is just a placeholder, not an actual file name. For example, this program reads an external file by using the FILEVAR equals option. Notice that in the SAS log, SAS uses the placeholder, dummy, to report the name of the external file that is being read. Suppose that we want to read a group of external files and concatenate them into one dataset. Each of the external files has identical formats. Instead of reading them individually, by using separate data steps, we can read them all by using the FILEVAR equals option in the infile statement in one single data step. The FILEVAR equals option will cause the infile statement to close the current input file and open a new one, which is obtained from the FILEVAR equals option. Recall that we used this program to read one single file. There are 3 statements in the data step, including an assignment statement to create the file name, infile, and input statements. To read multiple files, we need to place these 3 statements inside a loop. By examining the names of the external files, such as text1, text2, and text3, we can construct an iterative do loop, and iterate between 1 and 3. Then we need to modify the assignment statement, to create the file name, by using the concatenation operator. Here's the modification of the assignment statement. Notice that the file name is created by concatenating 3 components. In the second component, we use the put function to convert I, that contains values of 1 to 3, into a character. We need to add an explicit output statement, to write the current contents from the PDV, to the output data set within the loop. Since we are using the FILEVAR equals option, to control closing the current input file, and opening a new file, SAS will not be able to detect the end of file marker. Thus, we also need to place a stop statement outside the loop. Now let's see how the data step executes at each iteration. One thing that I made changes in this program, is the name of the variable to store the file name. The variable name becomes next. At the beginning of the first iteration, _n_ is set to 1. The rest of the variables are set to missing. At beginning of the do loop, I is initialized with value 1. The external file name is created. The infile statement copies the first data line from text1.txt into the input buffer. The input statement reads data values, from the input buffer to the PDV. The output statement copies the data from the PDV, to the output data. SAS reaches the end of the do loop. SAS returns to the second iteration of the do loop. I is incremented to 2. The second file name is created. The infile statement copies the first data line, from text2.txt to the input buffer. But wait! The program didn't read the second record of the first file. Only the first observation from the external file was sent to the designated output dataset. The reason is that, when a single iteration of the do loop has been completed, the following iteration starts to read from a new file, that is specified by the next variable. To read all the observations of each file, we can utilize the end equals option, and include a do until loop, within the iterated do loop. Now let's start over. At beginning of the do loop, I is initialized to 1. The first file name is created. Recall that, the do until loop evaluates the condition, at the end of the loop. The infile statement copies the first record, from the first file into the input buffer. The input statement copies the contents, from the input buffer to the PDV. The output statement generates the first observation. SAS reaches the end of the inner loop. Since the temporary variable last does not equal 1, the inner loop continues. The do until loop only evaluates the condition, at the end of the loop. The infile statement copies the second data line, from the first input data to the input buffer. The input statement reads the data value, from the input buffer to the PDV. The output statement generates the second observation in the output data. SAS reaches the end of the inner loop. Since last equals 1, the inner loop ends. SAS reaches the end of the outer loop, and continues to next iteration. At beginning of the second iteration of the outer loop, I is incremented to 2. Since I is less than, or equal to 3, the second iteration of the outer loop continues. The second file name is generated. The inner loop starts. The infile statement reads first data line, from the second file into the input buffer. Since this is not the last record of the second input file, the variable last is set to 0. The input statement reads data values, from the input buffer to the PDV. The output statement copies the contents, from PDV to the output data. At this point, 3 observations are created in the output data. Let's just skip the rest of the iteration. Loop is a very powerful programming structure, that can be applied to many programming scenarios, such as the examples that we saw in this video. Many applications that utilize array processing also require using loop structures. I hope you enjoyed this video. Please subscribe to my channel and click the bell icon to get new video updates.